There was a theorem involving the eigenvalues. I didn't catch the name of it.
Hamilton was a prodigy by age, I forget the usual English thing, but age 13, by age 3, he was reading classical Greek. By age 13, he spoke 20 classical languages. Then he had a nervous breakdown, as the British prodigies often do, and he decided to relax by studying optics. And he invented the modern, one version of modern mechanics, Hamiltonian, but he also invented quaternions and other things. Then he became a professor, an alcoholic, and a general nuisance. And Cayley was another British mathematician, and in the 19th century, they still suffered from having been made to hate everybody by Newton, so they hated anybody from the continent. So they did this provincial mathematics. So while Jacobi, Euler, Lagrange, all these amazing French, German, Russians, etc., did amazing mathematics, these guys did matrices. So that's a Hamilton-Cayley theory.
Yeah, that's right. That's the name. Could you explain, I guess, like what is the point? What is the main point of the theorem?
Amazing thing about the theorem is that suppose that Google collects data. That's called a Google matrix. The original version designed by 2 Stanford students looking at the matrix, and they tried to find the most important things in libraries originally. So that's a Google matrix. It has elements A1, A1, 2, and then it has element A1 to the n. So the Google matrix, it's a huge, huge matrix. This theorem says an amazing thing. You take the product of this matrix minus its eigenvalues multiplied by the unit matrix over all eigenvalues. And you find 0. Now, this has 10 to the 14 elements in it. This is a matrix. So you have found 10 to the 14 relations because for each component, this is 0. Where did it come from? I just derived you for it, in front of your very own eyes. But basically what it says is that if you solve the equation x minus lambda I, and this is a characteristic equation for one variable, 1, not 10 to the trillion, 1. Then you can promote it by the magic of this week to matrices, which can be of arbitrary size. And indeed, in our research and criminal activities like working on stock market, etc., these are huge matrices. So that's the point of Hamilton-Cayley. It was very surprising that you could, that's where people started appreciating functions of matrices.